state calls Dr. Mondor to the stand, M-O-N-D-O-R.
Good morning, sir. Please raise your right hand and face the clerk.
Do you swear and affirm your testimony that you're about to give will be the truth, the whole truth, and nothing but the truth, so help you God?
I do.
Please have a seat, sir.
Thank you.
If you would, position yourself close enough to that microphone so we can all hear you well.
Okay, sounds good.
Yes, ma'am.
Good morning, sir.
Good morning.
Can you please state and spell your full name for the court reporter?
Sure, so I'm Dr. Edward Mondor, E-D-W-A-R-D, M-O-N-D-O-R.
And doctor, what do you do for a living?
So I'm an entomologist. I'm the sole proprietor of Fear Lab, LLC, that stands for Forensic Entomology Applied Research. And I'm also an associate professor of biology at Georgia Southern University in Statesboro, Georgia.
Can you tell us what an entomologist is?
Sure. So an entomologist is one that studies insects. They study insect life cycles, behavior. They identify what different types of insects are for many different types of purposes: agricultural purposes, pest control, and in this case, medical legal issues.
Can you describe your education and experience related to entomology?
Sure. So I have a Bachelor's of Science degree from Brandon University in Brandon, Manitoba, Canada. I have a Master's in Zoology degree from the University of Alberta in Edmonton, Alberta, Canada. I have a PhD in biology from Simon Fraser University in Burnaby, British Columbia, Canada. I then did a postdoctoral appointment at the University of Calgary in Calgary, Alberta, Canada. I split time with University of California, Davis in Davis, California. I then did a postdoctoral appointment at the University of Wisconsin in Madison, Wisconsin. I then got hired as a junior entomologist at the University of Hawaii in Kapaa, Hawaii. And since 2006, I was hired as an assistant professor at Georgia Southern University in Statesboro, Georgia. I was then tenured and promoted to associate professor, and that is my current position today.
How long have you been in Georgia then?
I've been in Georgia since 2006.
And you indicated that your proprietary business deals with forensic entomology and research. Is that correct?
That's correct.
Does your research include this geographical area, meaning the southeastern portion of Georgia?
It does.
Thank you. I'm assuming that's in the field of entomology?
Correct.
Are there required certifications or licenses required for practicing specifically in your field?
There are no required certifications or licenses to be an entomologist or a forensic entomologist.
Is that why you do schooling and training?
Correct.
Okay. And how long have you been an entomologist and studying to become one?
I have been an entomologist now. My first research project, I've been conducting insect research projects now for 31 years. And I've been doing forensic entomology cases for 13 years.
Have you published any peer-reviewed articles, delivered scientific presentations, or taught university lectures in entomology and forensic entomology?
I have. So at this current point, and I say that because a resume or a CV is always a living document. It changes week to week. At this current point, I have approximately 45 peer-reviewed journal articles, and approximately 7 of those are based around forensic entomology topics. For presentations that I've given to conferences, different audiences, both between myself and the students in my lab that I oversee, I have presented 170 different presentations. 57 of those are about forensic entomology topics. I also teach courses based on entomology. For example, at Georgia Southern University, I teach a non-majors entomology course called Insects and People. I also teach a majors course called Insect Ecology, where we deal with insects, identification, life cycles, behavior. And I also routinely teach a course to both biology undergraduates and graduates, cross-listed, called Forensic Biology. In that forensic biology, we have a whole unit on forensic entomology, which consists of both lecture and lab.
Have you ever previously testified as an expert witness in forensic entomology in a court of law?
I have. So I've testified in Chatham County in a forensic entomology case there in 2013.
And in that case, were you qualified as an expert in the field of forensic entomology?
I was.
And did that include the analysis of the insects and the use of that in the court presentation?
Correct. So that was a civil case, and yes, I was confirmed as an entomologist.
Can you briefly explain what forensic entomology is as it is applied to the context of death investigations?
Sure. So forensic entomology is kind of a wide-ranging field. There's different areas or subspecialties of forensic entomology. They really break down into 3 different types. One is stored product pests. Those are insects that infest food supplies, whether it's rice, grits, flour, etc. The second is urban cases. Those are cases that involve places in cities, schools, hospitals, prisons. If you buy a house, it's got termites infested with it, you might call a forensic entomologist. This case here is what we call medical legal. That involves insects that are infesting either living or deceased individuals.
And you indicated that you testified in a civil setting, is that correct?
Correct.
So does your work cover both civil and criminal potentially in courtrooms?
It does. I have done both civil and criminal cases.
Okay. Do you work specifically for law enforcement or only in the capacity that you described?
I do not. I do not work for law enforcement.
At this time, Your Honor, the state would seek to introduce Dr. Mondor as an expert in the field of forensic entomology and the analysis of the substances, the insects, in relation to this case.
Any questions from the defense?
No questions and no objection.
All right, then he is so qualified as an expert in the field of forensic entomology. You may continue.
Now, can you tell the jury what specifically you were asked to do in connection with this case?
Sure. So for any forensic entomology case, the reason we like to use insects is because in many situations, you can't really use other things about the body to determine what we say colloquially, time of death. We don't really determine a time of death. What we do as forensic entomologists is we determine a time of colonization. That is, when do the insects first come to the body and lay their eggs on the body and develop to the stages that are then eventually found. So the reason we can use insects in these cases is really because of 2 main things. One is insects can't regulate their body temperature like we can. They're dependent on the external environment. So we use a fancy term in biology called poikilothermic. Growing up, we always used to refer to that as cold-blooded. Right? They're cold-blooded, they can't regulate their body temperature, they're reliant on the external temperature. So we could use them in effect like a biological clock because their development is strictly dependent on the temperature of the environment in which they are raised. The second thing that really helps us out with forensic entomology is they have a skeleton on the outside of the body as opposed to ours, which is on the inside. As a result, like a crab, they have to crack the old one off and develop a new one, so they grow in very discrete steps. And every step is completely different from every other step, so they're much easier to identify. So in this case, what we did was we had insect evidence that was collected, and I analyzed the insect evidence to see approximately how long it would take for them to get to that stage that was found.
Okay, so if we can go back to December 5th of 2022, did you receive a telephone call in connection with this case?
I did.
And without telling us exactly what was said, did you speak with any members of law enforcement?
I did.
As a result of that conversation, did you give them any guidance with respect to collecting the specimen that you ultimately examined in this case?
I did.
And did that conversation discuss how, in fact, they were to do so?
Correct.
And was that in real time?
Correct.
When you were giving those instructions, ultimately, did you anticipate receiving a sample?
I did.
Did law enforcement tell you any particulars about the case other than that they were submitting a forensic insect sample to you?
They did not.
Okay. At some point, did you receive any photographs?
I did.
And did you have an opportunity to view those photographs?
I did.
Your Honor, I am not going to publish, but I'm just going to show the witness 1.1AA, which I am showing to counsel now. May I approach the witness?
Yes, ma'am.
Do you recognize the segment of that photograph that is displayed in that photograph?
Yes.
Okay, you can just turn that down if that's
Okay.
okay. Was that one of the photographs or what you received?
I believe it was.
Okay. And can you tell the jury, when you received the photographs, did you ultimately receive also a, quote, live sample? Or not live, but processed sample, perhaps is a
I
better
received a
phrasing.
process sample, so they were all dead at the time, correct?
Okay. Can you tell the jury exactly how that sample gets to that condition?
Sure. So when, I can't say when I talk with somebody. So when I received that sample, what you always do with insect samples, especially if you have insect larvae, which are maggots, what we call them, the first thing you should always do is you should put them in boiling water. The reason you put them in boiling water is so then they don't start curling up and they're difficult to measure, they're difficult to identify. It kills a lot of the bacteria on them. Once they're done in the boiling water, you then put them into alcohol, which preserves them, and as long as they're preserved, they will last almost indefinitely. So those are the samples that I received, were the ones that were in preservative inside a jar.
And were they in a condition that was sufficient for you to examine and analyze them?
Yes.
For lack of being graphic, you indicated that they would curl up potentially. What condition do they remain in if they are processed in boiling water and subsequently placed into alcohol?
They will be very nice and straight and long, and so if anybody wants to measure them, they can measure them, and they're much, much easier to identify as well.
And that process, does it do anything with respect to their life cycle?
It stops it. So as soon as you put them in the boiling water, it kills them almost instantly, and that stops, again, what we call that biological clock. So that is the point from which we start to work backwards to figure out that time of colonization, when the insects first come to lay the eggs on those remains.
And do you know the portion of human remains from which this was recovered?
Could you
sample.
rephrase that?
Do you know where the maggots were recovered from that were provided to you by observing that photograph?
So the maggots that were recovered were collected from where the leg appeared to be separated from the rest of the body. In the photograph, you can see that there is extensive insect colonization, once again, insect larvae, what we call maggots, on that portion of the leg that is exposed.
Can you tell us what MPMI means?
Sure. So a minimum post-mortem interval estimate is what we really try to evaluate. A lot of people are under the misapprehension that we try to estimate a time of death. We don't. Really, medical doctors are ones that estimate what a time of death is. When we determine what our time of colonization is, so when those insects come and lay the egg on the body, that duration of time then, from that time of colonization to when they found the body, so what we always say, death to discovery, that's our minimum post-mortem interval estimate. So it's an interval, it's a length of time, and we always say minimum because we determine that the person has been deceased at least that long.
And in performing that analysis, would it be fair to say that that would have been when they would have been exposed to the actual insects to lay the eggs on the remains?
That's correct.
Now, when you received those photographs, tell the jury what you did with the photographs first.
So with the photographs, and I also believe what I did is I always look at the photographs, right? So the first thing you have to do is you have to look at the photographs, see if there's anything in that photograph that might not be in the sample, right? So once we get the sample, we always want to have the photographs so we can go back to the photographs and actually verify that there isn't some later stage observable in the photograph that wasn't collected at the scene.
So to be fair, I believe your testimony was that there were quite a bit of insect activity at that portion of, would it be fair to say, the thigh?
Correct.
Okay. And so would that demonstrate more than one maggot to look at visually with the naked eye for you to observe?
Absolutely.
And did you do that in the fashion you just described to determine if potentially there was a maggot at a different life cycle stage?
Correct.
So could they be growing at different rates?
Correct.
And did you ascertain and ensure that that information that you were looking at was accurate to what you observed?
Correct. So from the photograph that I have and the sample that I collected, I did not see any later stages in the sample as opposed to in the photograph.
Okay. And can you explain to the jury, when you received that, did that come also with the sample itself, the processed sample?
Sorry, could you restate that?
Did the photographs come to you separately, or did you get them all at the same time, if you know?
I believe I got them separately.
Okay, so you received the photographs and ultimately then received the sample?
Correct.
Okay, and when you received the sample, was the sample in a fashion that you could analyze it?
Correct.
Tell the jury what you did when you received the physical sample.
So when you receive the physical sample, the first thing you do is you have to identify what the insects are. You also have to know what the stage of the insect is. So the first process that we always do is we do what we call morphological identification. Fancy term, we put the insects under a microscope, and using a dichotomous key, we go through the different traits that the larvae have and identify them to species. We also wanted to be doubly sure that we knew what we had and it was the right species that we had keyed it out to, so we also did genetic analyses. And the genetic analyses did confirm what we found under the microscope.
When you say genetic analyses, would it be fair to say that's DNA?
It is correct.
And in this case, that would be the maggot DNA?
Correct.
So you looked at them first under a microscope, and then subsequently you actually took the DNA from the specimen that you received?
Correct.
And in this case, did you determine what species of insect you had before you?
Yes.
What type was it?
So it was a common blowfly that we have in this area, which is in insect order Diptera, family Califoridae, and the name is Lucilia sorulaviridi. Very difficult name to pronounce, literally translates as blue-green.
So that's the blowfly that you were describing?
Correct.
And in this case, was that the only species?
That was the only species. Everything we identified morphologically and genetically came out to that one single species.
Is that always the case?
It is not.
And in this case, did that make it in any way easier for you or harder?
It was actually easier because then we only need to construct one thermal summation model.
Okay, so based on the fact that there was just one species, you were able to do your model based only on that life cycle?
Correct.
Okay. And what is the typical life cycle for and I will not try to pronounce that scientific name, for the blowfly that you found here?
Yeah, so the blowflies, so those ones are very, very common in this area. In fact, all throughout South Georgia, that's probably the most common blowfly that we have. In many experiments that we've done personally in our lab, that tends to be the dominant blowfly. We can also find it through all seasons of the year. That fly will come, of course, you have males and females. They're sexual, they mate. The female then will come to the body. She will lay her egg on that body. The egg then hatches and goes through different larval instars. So those are the maggots, right? So first stage, what we call first instar. It then molts, goes to the second instar. Molts, goes to the third instar. Those are the big maggots. That's the last stage. After that, we get the pupal stage. That's like the cocoon of the butterfly. And then after the pupal stage, the adult fly comes out of that pupal stage.
Now, you've used the word molt when referencing the shifting from one phase to the other. Can you tell the jury what molting means?
Sure. So molting is basically cracking off that old exoskeleton and forming a new one underneath it. So they grow not gradually like we do, but very discrete steps and stages.
And can you actually see the difference of what they look like at each of those stages visually?
Correct, you can.
And can you then subsequently confirm that microscopically?
We do.
Did you in this case?
Yes, and that's how we actually identify or confirm the different ages, is microscopically.
Now, can you explain the scientific methodology that you utilized to arrive at your minimum post-mortem interval?
Sure. So there's really 4 different things that you need in order to determine what we call an MPMI, right? And we'll use that phrase for shorthand. You need to know the species of the insect. You need to know the age of the insect. So what instar is it? You need to know the temperature conditions of where that body was located. You then have to have somebody who has raised that particular species in the lab before to know how long it takes to get to those different stages at different temperatures. And then once you have those 4 things, you can build your thermal degree model to figure out what that time of colonization was, which of course leads to that MPMI estimate.
And in your analysis in this case, I believe you have already testified that you determined what type of insect it was.
Correct.
Did you then have the ability to make a determination as to the stage of life of these maggots that you received?
I did.
And what was that?
They were third instars, the oldest stage. So there was multiple stages. There was second instars and there was third instars. So they were all maggots in that maggot stage.
Okay. And so at that point, when you determined the species and the age of the insects, did you do anything with respect to obtaining air temperatures and the climate surrounding their recovery?
I did. So I went online and got air temperatures for the closest weather station that was close to where the remains were found. I went to an online site called Meso West. It's done by the Department of Atmospheric Sciences at the University of Utah. They basically take National Weather Service data, which is part of NOAA, the National Oceanic and Atmospheric Administration. That is considered to be the best weather data that we have. I got the weather data from there and used that in my thermal summation model to figure out how long it would take the insects to develop to that stage.
And to be fair, you used the word estimate.
Correct.
Is forensic entomology able to give a precise moment of when an egg was laid on human remains?
And it is not. That's a lot of what we see on TV. You can't have an exact estimate because there's always variability associated with it. So every time we come up with a minimum postmortem interval, we always say that it's an estimate. It can, though, depending upon the situation, be pretty accurate, especially when there's no other methods that we can use to estimate what that postmortem interval is.
So would it be fair to say that when you provide an estimate, you give a range?
That's correct.
And is that range in hours, minutes, days? How does that work?
Because I do my thermal summation model in accumulated degree days, I tend to give my variation also in days.
Okay. And did you do that in this case as well?
I did.
Based on your analysis of the developmental stages of these insect species, what is your expert opinion regarding the minimum postmortem interval for the deceased?
Can I refer to my notes?
Actually, Your Honor, I may just approach first. I'm showing counsel 1.100. I'm going to hand you what is marked for that exhibit and ask you if you recognize that.
Perfect. Yes, and in fact, this is the same report that I brought with me today.
Okay. Just want to make sure we're working off of one that remains in the courtroom. What is that document that's in your hand?
This is the estimation of the minimum postmortem interval collected from the human remains that I always produce after I actually do an actual case for law enforcement.
And did you generate that report that you're holding 1.100?
Yes.
Is that a true, accurate, and complete copy of the report that you prepared?
Yes.
Your Honor, at this time I'd seek to tender 1.100.
No objections.
Why do you do a report?
I do a report largely for situations like this when it may turn into something much larger than just wanting to know what the minimum postmortem interval is.
Okay.
For many of the cases that we do, it's families that might just seek closure knowing how long their deceased has been deceased. In other cases, it might turn into civil or criminal matters.
Okay. So in all of the cases that you handle, do you always testify?
I do not.
In fact, more often than not, do you testify or not?
More often than not, I do not.
Okay. Can you tell us in the course of your experience, approximately how many postmortem intervals you think you've estimated?
So at this point now, between cases that I've done reports for or just consulted on with other forensic entomologists, approximately 40 cases.
Okay. And did you have to follow those same procedures in every single step that you just described here?
For the ones that are generating reports, yes.
Okay. And now we had gotten to that question based on your analysis of the materials that you received in this case, both the photographs and the physical sample. What is your expert opinion regarding the minimum postmortem interval for the deceased?
So mathematically, when we calculate what that time of colonization is, it comes to November the 28th, 2022. Like I said, there's always a range associated with that, and the range is November 27th to 29th, 2022.
So your estimate includes the dates of November 27th, 28th, and 29th of 2022?
Correct.
Okay. So at that point, did you know when you generated that date from law enforcement exactly when her remains were recovered?
The only thing that I knew at that point was when the leg with the insects on it was recovered.
So you didn't know that her torso had been recovered on December 2nd of 2022?
That's correct.
Did you know that her other leg was recovered on December 3rd of 2022?
I did not.
Did you know that her head was buried?
I did not.
Did you even know that it was found?
I don't think I did.
Okay. And did anybody show you any video surveillance footage of a motor vehicle coming to that vicinity on November 29th of 2022?
No.
And the methods that you've described for your procedure here, are those the standard practices that are utilized by forensic entomologists across the country?
Yes, so determining species IDs or the identification of the species using a microscope, genetic analyses, that's standard procedure. Also, thermal summation models using accumulated degree days, using temperatures is standard procedure for the field.
If I can have just a moment. I have nothing further, Your Honor.
Mr. Weinstein? Good morning, Dr. Mondor.
Good morning.
My name is Doug Weinstein. I'm representing Mr. Kassotis in this case. I'd just like to ask you a few questions. In your report, Exhibit 1.100, I believe you have it in front of you, correct?
Correct.
You state that, let me see here, the average temperature of the environment that you found online was 15.7 degrees C during the 2 weeks prior to the discovery of the remains, correct?
Correct.
And you state that 22 degrees C is the closest insect rearing temperature available in the literature, correct?
That is correct.
Okay. And what's that difference in temperature in degrees C?
That's a math question.
I'm sorry, if I said it was 6.3 degrees C, would that be about right?
I would agree to that.
Okay. And to turn that into American, that's about 11 degrees F, right?
That's possible.
Okay. So, are your calculations based on that literature that showed it at 22 degrees C?
Correct.
Okay. How would your estimate, or could your estimate be different because it was 15.7 degrees C instead of 22?
So what we always do when we do a forensic entomology estimate is we always use the closest temperature, the closest rearing temperature to what that field temperature was. In this case, for this particular species, the closest rearing temperature that had been done previously to this field temperature was 22 degrees Celsius.
But it wasn't 22 degrees C at the site, correct? At the site where the leg was found.
Correct.
It was 15.7 degrees C, correct?
Correct.
And you could not find literature showing 15.7 degrees C.
That's correct.
So it's possible that your estimate could be off because 15.7 versus 22?
There's always variability, correct.
Okay. In addition, you write, and if I'm reading this wrong, just let me know, this ADD, that's average degree days, correct?
Could you point me to a
Sure.
particular page?
In that same analysis section of your report on page, I believe it's labeled page 5 of 7.
Okay.
That same section, near the bottom of the page.
Okay.
You state this ADD value is based on a fly population from a mixed hardwood forest in Oakwood, Georgia.
Correct.
Okay. Do you know where Oakwood, Georgia is?
I do. It's in North Georgia.
Right. It's near the Falcons training camp, I believe. So it's in North Georgia, and Oakwood. That's at a higher altitude than us here down on the coast, correct?
Correct.
It also says that it is from a mixed hardwood forest, correct?
Correct.
Do you know what the forest was like where the remains were found?
I do not.
If that forest were a pine forest or a planting of pine trees, that's different than a hardwood forest, correct?
It is.
Could the fact that the analysis that you had to reference was from a hardwood forest versus a pine forest, could that make a difference in colonization?
It would be unlikely.
What about the difference in altitude between Oakwood, Georgia and the coast?
You definitely get geographic differences between different fly populations in different species. Once again, what you always try to do is you always try to use the data from a population that's as close to you as possible. In this case, the literature from Oakwood, Georgia, was the closest fly population possible that we could use.
Does colonization, am I using the right term of colonization?
Correct.
Okay. Does the colonization vary depending on whether the remains were in the sun or in the shade?
It can.
And when you use that colonization information that you were able to find from Oakwood, Georgia, do you know whether that was performed in Oakwood in the sun or the shade?
So to clarify, this experiment that was done, this was a fly population that was collected from Oakwood, Georgia. The rearing was actually done in the laboratory. And I know this because I'm actually an author on that paper.
Okay. So but it does make a difference if it's sun or shade, correct?
It could.
Do you know whether the leg was found in the sun or the shade?
I don't.
So you didn't factor that into your analysis, correct?
That's correct.
And you may have referenced this earlier, so I apologize if I'm repeating what you've already testified. Can the colonization be delayed if the body was wrapped or in plastic or buried?
Correct.
And how might that affect the colonization?
So if you have a body that is wrapped or buried or somehow restricts access of the insects to that body, that could definitely delay the colonization. That is the main reason we always construct a minimum postmortem interval to say that the person has been deceased at least that long.
And again, your estimate is also based on the location where the remains were found. If the remains were moved, then your estimate might be different. Is that accurate?
That's correct.
Okay, and just to repeat what you've already, I think, have been clear on, but I want to make sure it's clear.
Okay.
Well, your minimum post-mortem interval, that is an estimate to the best of your ability, correct?
That's correct.
That is not exact.
That's correct.
All right, thank you very much.
You gave a range, right, Doctor?
Correct.
Does that range account for some of the variability that counsel is asking you questions about?
It does. So it will account for things like certain weather conditions, if there's flies in the area, how close the flies were, anything that might restrict it. So it always is a range, right? As we say, we can't have an exact time, but yes, there's definitely a range.
And that 3-day period, is that what builds in that range?
It does, with assuming all of the variables that we have and the best information that we have at the time.
I have nothing further.
Anything else?
Does that range account for all of the differences that we discussed today? For example, the change in altitude, the different location of where the study is found, the temperature difference between the study and at the remains, the possibility of the remains being wrapped, the possibility of the remains being removed.
If they had been wrapped or moved, then it would not be in that variation.
Okay, thank you.
Yeah.
All right. Thank you, Doctor.
Okay.